Hello everyone, welcome to Electronically Connected. So in this video, we'll be focusing on what a full adder is. We'll be discussing how to construct a full adder using basic gates like XOR and OR. And in the next part of the video, we'll be discussing how to construct a full adder using half adders. So let's get started. We have discussed in the previous videos that a half adder is not effective for adding more than 2 digits. And that is how a full adder comes to the picture and removes the difficulties and limitations of a half adder. The difference of a full adder block from a half adder block is that it has 3 inputs. It has input A, input B, similarly to the half adder. Then we have an input C in. This is my input carry. And on the output side, we have the same thing. We have a carry and sum. And this carry, we're going to write it as C out. Let us first discuss the truth table behind a full adder. So for 0, 0, 0, adding all 3 of them together, we have 0 sum and 0 in carry. 0 plus 0 plus 1, so 1 in the sum, 0 in carry. Similarly, 1, 0. Now 0, 1 and 1. 1 plus 1 is 2 and 1, 0 is basically 1 in the carry, 0 in the sum. Again, 1, 0. 1 plus 0 plus 1. Again, this is 2, so 1 in the carry, 0 in the sum. Similarly, in this case and in the last case where it's 1 plus 1 plus 1, that is 3. And 3, 1 plus 1 plus 1 is equal to 3. And 3 in binary is written as 1, 1. So, 1 in the carry and 1 in the sum. Now, let us see how can we form equations for our sum and carry. So we will be using K-map for sum and carry. Let's draw the K-map first for sum. So here we can see that all the ones are distributed evenly and hence it cannot be grouped. So that means we have 4 equations. Here we have the equations from this K-map for sum. So my S for sum is equal to, after using Boolean algebra on this, we will find the sum is equal to A bar B XOR C plus A B XOR C. And this, if we write, it gives you A XOR B XOR C. And this is the equation of my sum for full adder. Now let us reduce the equation for carry. So for carry, let's draw the K-map for carry now. Now we can see that the ones can be grouped together. So we have, this is my one group, second group and third group. So let us write the equation. First group will give you AB plus BC and plus AC. And there we have it. This is my equation for carry. So we can see that if we want to construct the circuit diagram of a full adder, we can see that we need one big XOR gate with 3 inputs A, B, C, and then for carry we need 3 AND gates because A dot C, B dot C, A dot B, and we need one OR gate to add all of this together. So let us see how to construct the circuit diagram of a full adder. Here we have the equations of sum and carry. We need one big XOR gate for our 3 inputs. So we have one XOR gate whose output is the sum. And the 3 inputs are A, B and C in my carry. So we have A, B and C in. And for carry we have 3 AND gates first. And the output of these AND gates are OR together. So we have a 3 input OR gate whose output is my carry. So each of these AND gates get 2 of the inputs. So we have AB, then we have BC, and then we have A and C. And there we have it. The circuit diagram of a full adder using the basic gates like XOR, AND and OR. Now let us discuss how to create a full adder using half adder. First, let's mark the inputs and outputs of a full adder. So let's draw a block. Let's just say this is the block of my full adder. This is my input for my input terminal and for my output terminal. So I have input A, input B and input C in. That is my carry. And on the output side I have a sum and I have a carry, which is my Cout. So to construct a full adder using a half adder, we need two half adder blocks. So let us draw two half adder blocks. We have, this is called half adder 1, and then we have another half adder over here. Let's call it half adder 2. So now the inputs A and B are connected to my half adder, and it acts as inputs A and B for my half adder. Then we have S1, sum 1 and carry 1. So the sum 1 from half adder is connected as one of the inputs of my half adder 2, and the C in acts as my next input for half adder. So the S2, that is a sum. Now this sum from the second half adder is a sum that we get at the output of my full adder. And next we have the carry. So here we have an OR gate which becomes the carry out, and the inputs of this OR gate are both the carries from the half adder blocks. So we have 1 and 2, and there we have it. Let us deduce the equations out of this. So from the first half adder, from the sum we have A XOR B, and the carry is A dot B. Now for my second half adder, the sum is the XORing of this input and this input. So the first input is A XOR B, and now this is XORed with C in, and there we have it. This is the sum. This is the equation of my sum of a full adder. Similarly for my carry out equation, so we have A dot B, and this is Cn dot A XOR B, because the carry equation of a half adder is A dot B. So we have A dot B, and in the half adder 2 case the carry is A XOR B ANDed with C in, and then both of these inputs from the carry out are all together, and we have a carry out for the full adder. And there we have it. This is how you use two full adder blocks to construct a full adder block. One of the biggest advantages of using a full adder is that it can be cascaded together for using for higher blocks. So for example, right now this is only for 1 bit, but if you cascade number of full adder blocks together, so that means we have one full adder cascaded together. This can be used for number of bits. This will be 1 bit, 2 bit, 3 bit, and if we have another one, we have 4 bit. So this will become a 4-bit adder. To discuss about the different types of adders and its construction, please watch my next video. With this, we come to the end of our video. Thank you for watching. Please like, share and subscribe to my channel. Till then, happy learning. See you next time.